Hello, good morning. Can you hear me?
Good morning. Yes. Can you hear us? Can you hear me? Oh. Mhm. 1, 2, 3. Just a moment. One, two, three. Yep. No. Oops. So it can be.
Okay, if you can hear me, maybe I can have my presentation, but I will not be available for questions. I cannot hear you. I do not know why. Everything seems to be fine. Because of Zoom.
So you still don't hear us, yeah? Okay. We'll try another one. Can you hear us now? No. Okay.
Maybe I will try disconnect and connect again. Let's see what will happen.
Okay. No.
What?
Okay. So.
And I can see that you are speaking.
Yeah.
It's
Okay.
indicated on my screen, but I cannot hear that. I'm trying another speaker. Say something now. No, it is just music.
Right now, can you hear us?
Now I can hear you.
Oh, okay.
There is some strange music behind, but it is like
Music. No music.
Okay. Now I can hear you. I need to only increase.
Yeah.
Hi, Vladimir.
Hi. I can hear you, but not
Yeah.
very loudly. Let me play a little bit with my. Okay, at least.
Yeah,
at
is it
At
okay?
least it works now.
You hear us, yeah?
Yes, I can hear you.
Ah, yeah,
Not very
perfect.
loudly, but I will do some. I can do some adjustment. Probably not with the Zoom, but say something, please.
Yeah, 1, 2, 3.
Yeah, still I can hear you like from the large distance, but maybe it's not so important. And I know that there was a trick to make it louder, but I don't see it.
We are
Was
hearing
in
you
Microsoft
perfectly.
Teams. Or maybe I will try this. Okay. Look, I can hear you like from the big distance, but it's probably not so important. Can you hear me well?
Yeah, very well.
Yeah, if you can hear me well, that's the most important. Yeah, and I am not in this mode. I am host disabled attendee screen sharing. So I sent to Anastasia my first presentation that is on the screen. And when we will have some short break, I will send another two.
Okay. Can you see the presentation?
Yes, I can see the presentation.
Okay. Okay. So just say the next slide and we will change the slides.
Yes, will do. I do not see lower part of the presentation, but it's not so important for me. I will open it in my
So
own
we can
screen.
see the full presentation. Yeah, the full.
Yeah, that's it. That's the most important, that you can see everything.
Okay.
Yeah.
Okay. So it is already time, and so please, Vladimir, Michal, you can start the floors. The floor is yours. Yeah, please.
Thank you so much. Just to clarify the timing, well, you have usually your lesson for like I don't know, 40 minutes, and after that you have some kind of break, or what is the timing? What is the arrangement?
For the first lecture, we have 45 minutes, but we have a coffee break after 1.5 hour.
Yeah.
So all the time is yours. Yeah.
Very good. Maybe then I can have I can have two presentations, after that coffee break, and after that I will have the last one.
Yeah. Okay.
Yeah. In this case, let me just quickly send to Anastasia. Or maybe I will do it after the first presentation.
Yeah. Okay.
Yeah.
No problem.
Just to let me know how many participants and from which countries do you have in the room?
So we have around 25 participants from Belarus, from Egypt, from Brazil, from Sri Lanka, Pakistan, Zambia, Ethiopia, Nigeria, Ghana, Turkey. Yeah, of course. Yeah, these countries.
Yeah, clear. Fine. Yeah, thank you. Let me increase my volume. Okay. Okay, so let me to start. Let me introduce myself once again. My name is Vladimir Michal. I am decommissioning team leader. I guess in nuclear energy department, I guess that you had yesterday presentations by Yulia Gorlova, by my colleague Yulia, right? Yeah, so she is from nuclear safety department. I am from nuclear energy department. So I will have it later on in my presentation. So obviously, nuclear safety and security is more focused on safety guides, safety development project, and my activities. I can see you now. My activities in my department, they are more focused on technical aspects of a variety of nuclear energy development, including the decommissioning. And in this presentation, I would like to highlight the global status of decommissioning of nuclear facilities to give you an overview of facilities and activities that are done in different countries of the world. Next slide, please. I guess that this introduction about the IEA was already introduced by Gloria. So just quickly repeat, but not by Gloria, by Julia. My section head is Gloria. We have recently 180 member states, so many professionals from many countries. And our headquarters is obviously in Vienna, but we do have also nuclear laboratories in Cybersdorf. There are some diplomatic offices in Geneva. There are marine laboratories in Monaco. And we do have also Associated Institute in Trieste. I have it there twice, I should correct it. New York, Toronto, Rio de Janeiro, and Tokyo. And this Associated Institute in Trieste is International Center for Theoretical Physics. Next slide, please. As I mentioned, two sections or two sections dealing with decommissioning. In my department, technical, we do develop technical guidelines and reports. We do have a variety of related projects. We support technical cooperation program. We do have a coordinated research project, several collaborating centers. We organize webinars, etc. In the Department of Nuclear Safety and Security, there is a Waste Environmental Safety section that also deals with decommissioning. And they are obviously focused on safety standards and activities to support their adoption by member states. But we have also a specific interest on decommissioning from Department of Safeguards. I will explain you later on why. Yeah, and in general, just to complete this picture about the IEA, we do have also Department of Nuclear Sciences and Applications. Also, we have some joint activities on decommissioning. We do have a technical cooperation department, so we have a projects on this topic in different countries. And Department of Management is our internal department for our activities. Next slide, please. Here is just the basic introduction, of main decommissioning strategies. So according to the General Safety Requirements Part 6 on decommissioning, the immediate dismantling, we are using such a wording, is a preferred strategy. Deferred dismantling is when facility is in a safe enclosure, is also a recognized strategy. Combination of both strategies is also possible. And in situ decommissioning, what is very diplomatic word for entombment, or simply leave the facility after some works at the stage at the site, can be considered as a solution under exceptional circumstances. Yeah, for example, after an accident. And on that picture, it is from one of our safety guideline. It's a very nice schematic, illustration of radiological hazards, how it is changing during the decommissioning when applying different dismantling strategies. So let's say during the operation is a radiological hazard more or less stable because of fuel, because of operation. During the transition phase between operation and decommissioning, it is decreasing because fuel can be removed, various circuits can be drained, Operational waste should be conditioned and can be done some cleaning and decontamination. And after that, depends on strategy for decommissioning, either safe enclosure or immediate dismantling. Radiological hazards either more quickly decrease down to zero, or during the safe enclosure, there is a slow decreasing because of natural decay, and final dismantling is done after some dedicated period. Can be up to 50 years, but it really depends on the country. Next slide, please. Here is another one nice picture that we developed for our bulletin. Published in the occasion of International Decommissioning Conference in May 2023. So here you do not see like hazards decreasing, but you do see schematic illustration of various pre-operation, operation, transition, and decommissioning phases. Yeah, it took us a lot of time to prepare it together with our designers, because, technical view and designer's view are not always very compatible, but we somehow succeed. Next slide, please. Yeah, I mentioned already that there is a certain interest from our Department of Safeguards on decommissioning. And they do have they use a little bit different wording. And for them, decommissioning is a little bit differently defined than for nuclear energy and nuclear safety department. For safety and energy departments, is decommissioning defined as an all administrative and technical action that that allow to remove regulatory supervision, regulatory license. For safeguards purposes, it's a little bit different. First of all, I try to, in blue, little bit incorporate it into the previous picture. So they do have certainly terminology operational facility, what is fine. Then after that, permanent shutdown facility, what is also fine. But after that, you can see the line that says that nuclear material removed. So I believe that it is a very important point in the safeguards considerations, that all nuclear fuel and all other nuclear material as defined is removed from the facility. And after that, they use terminology closed down facility, and they are still doing safeguards duties there until the moment that the main essential equipment, like reactor pressure vessel or steam generators or simply primary circuit, is I will use the word destroyed, but dismantled, maybe it's better word, or deactivated in a way that facility cannot anymore store, keep, reuse whatever nuclear fuel and nuclear materials. Yes, for example, when a pressure vessel is cut from the primary circuit and removed to other place for cutting, at this moment the facility is decommissioned. You can see the line, decommissioned for safeguards purposes. It is a terminology that is used. And after that, safeguards supervision is not requested anymore. But from the viewpoint of safety and safety, security, and nuclear energy, is facility still not decommissioned because license continues to be in place. Some residual radioactivity can be still in place and needs to be fixed. So this is the little bit the reason, just to highlight for you that there are two different views, though compatible views, to the decommissioning. Next slide, please. Yeah, here I would like to highlight that some years ago we initiated a project called Global Status of Decommissioning, This project, the aim of this project is to collect information from all over the world about the status of decommissioning of nuclear installations. And under the nuclear installations, we do understand, of course, that power reactors, research reactors, but also other nuclear installation as per the IAEA definition. Yeah. So we issued the first report that you can see in the screen. It is a nuclear energy series report in April 2023. It was done by purpose because there was this conference in May 2023. And second round of the project started in 2024 with the aim to have second revision of the report published in some couple of years and maybe again before the another decommissioning conference. Report is widely based on the IAEA databases. I will show you some information later on, and also inputs from member states. And it is not only like collection of data, but also it includes analysis of recent development and expected trends for the future in different areas, you know, not only technicalities, but also human resources development and new trends such as artificial intelligence and circular economy, etc. Next slide, please. Yeah. So now I would like to talk a little bit really about the global status. What was before was just introduction. And I will start with the power reactors. We do operate a database called PRIS, what is a Power Reactor Information System. I think that everybody can has access. I do have a full access, but there is also access for external people. And I checked those data yesterday or day before yesterday, so they are really fresh. So recently we have such a number. You can see 416 power reactors in operation. There are some 23 in suspended operation. There are some reactors under the construction. And historically, 215 reactors were shut down for decommissioning. And out of it, only 23 have the status fully decommissioned. And those are in countries like Germany, Japan, Switzerland, and USA. And I believe, I know that there are more such power reactors that might be considered as a fully decommissioned, but because they are part of the larger site, or maybe there are some commercial activities, they officially do not have such a status. So sometimes I add to this presentation that 23 plus fully decommissioned. And I do expect that soon will be more reactors officially fully decommissioned. Well, I noted here countries like Belgium with the BR3 reactor, Russian Federation with Obninsk reactor, Slovakia, V1 NPP is very close to be decommissioned, Spain, Jose Cabrera NPP, and couple more. And I believe that it is also interesting picture with age of power reactors that are now in the world. It is also freshly updated. It is in this database PRIS. And as you can see, peak of age of power reactors is about, recently in the world, is about 40 years. And there are even older reactors, 50 years and so on. So all of those are candidates for the future decommissioning. And as the years will come, this graph will move, towards the end. Yeah, maybe 50, maybe 60 years, it is a maximum. But anyway, after that, the reactor needs to be shut down for decommissioning. So it is obvious that peak will come in the next decade or two, and there will be a lot of work to do. Next slide, please. Yes, here you can see a recent list of countries with a number of shut down power reactors for decommissioning, and also types of power reactors shut down for decommissioning. In terms of countries, please consider this blue light line. This dark blue line is, I think that it is installed capacity, so it is not so important now. So blue light or light blue line, as you can see, the highest number of power reactors shut down for decommissioning are in USA, 41, I guess. Then United Kingdom, 36. Majority of them are graphite reactors. I will speak about that a little bit later. Then we have Germany. Yes, all power reactors shut down for decommissioning. Then Japan, 27, I guess. Then France, 14. Russian Federation, 11. And then you have other countries, Sweden, Canada, Ukraine, and other countries that do have shut down 4, 3, 2, 1, up to one reactor. Yes, for example, Kazakhstan, Pakistan, Armenia, of course. It's interesting that in the list are still not yet countries with quite a significant nuclear power program. So I guess that in the future the list will be longer. For example, you cannot see here China. China still didn't shut down any power reactor for decommissioning, though they do have quite a few. India also not here, also for the future. Then countries with a smaller fleet but still significant, Czech Republic, they do have 6 power reactors, all of them in operation. And other countries. I also do not see here any country from South America. Yes, they also do have in operation Brazil, Argentina, right, Mexico, South Africa, also a couple of reactors there. So list. I just want to say that list of countries will be longer in future. And in terms of types of power reactors, you can see that the highest number are pressurized water reactors, yes, because they are most available in the world. Then boiling water reactors, then gas-cooled reactors, and there are other types, light water gas-cooled reactors and pressurized heavy water reactors and fast breeder reactors, and other reactors of different types, some of them kind of exotic from the first fleet of generation of power reactors in the world, when different concepts were tested. Yeah, next slide, please. And here I allow myself to do certain prediction, for the future. And by purpose is this prediction after 2025 covered by this small picture, because of course that this everything will very much depends on the lifetime extension of the reactors, because now we are speaking about possible lifetime after up to 60 years. So in the future, number of power reactors shut down for decommissioning will grow, but I do believe that there was a certain peak when Germany shut down all their reactors for decommissioning, and after that increase will be lower. And hopefully also number of power reactors officially decommissioned will grow. And don't be confused with those years there. You can see actually there are important points like IEA conferences on decommissioning. So there was one in Berlin, 2002, then Athens, 2006, Fukushima accident as an important point, mentioned here as well. Conference in Madrid, 2016, to another one in Vienna, and now we are in 2025. Very good. Next slide, please. Okay, so let's move to research reactors. We have also database. It is a very boring title, Research Reactor Database. Yeah. And recently there are 227 operational research reactors, 23 reactors that are under construction or planned. Then we do have 124 reactors that are permanently shut down or under the decommissioning. And this number is surprising, but not really. We have 456 reactors that are officially decommissioned. So picture is very much different from the power reactors, yes, because we have more research reactors decommissioned than recently in operation. Yes, on the picture you can see distribution of power reactors in different geographical localities. Next slide, please. Yeah, also this picture with estimated development after 2025, you can see is very much different. So as I said, we have now well over 400 reactors decommissioned, research reactors decommissioned. And actually, it is expected that number of research reactors shut down for decommissioning will be lower and lower because this basis will be lower and lower. Yeah. So of course that research reactors are specific, that they can be really in operation very long. They can be more easily reconstructed than power reactors. That can be changes in the power, changes of the fuel. So research reactors offer more flexibility in this sense. Next slide, please. We have also various databases for fuel cycle facilities. And there is one that provides overview of such facilities. They do have a little bit also different like operational categories. So I try to summarize it here, that there are recently over 870 facilities like registered, 409 in operation, 38 under construction, 173 shut down or under the decommissioning, and 159 decommissioned. So it seems that here is a picture somewhere in between power reactors and research reactors, because there are still, maybe we can have a look to the next picture. Next slide, please. So there are still quite a few fuel cycle facilities decommissioned, but there are still many of them, existing, and somewhere in the near future they will be like, this number will be equal. Though I have to say that maybe this picture, because it is just estimation, will change somehow in the future, because with the growing interest in operation of nuclear facilities, and also maybe growing fleet of small modular reactors in the future, they will be also need in more fuel cycle facilities, because they need to produce fuel for such an expected large fleet of small modular reactors. So let's see, maybe this picture will change. And here you can see also age distribution of fuel cycle facilities. So you can see that there is some kind of peak, but it is not so dramatic like in case of power reactors. And many of those fuel cycle facilities are rather younger than older, So the real peak will come really in the mid-term, long-term future. It is certainly not like in the critical stage now. Yeah, next slide, please. And now I would like to just highlight for you that actually there are many other nuclear facilities to be decommissioned in the future. I do not have such a clear picture about that, but it may be addressed in this report on global status of decommissioning that I introduced in a first or second slide. And those facilities that needs to be decommissioned are industrial radiological facilities, from small to large. For example, industrial irradiators of the food and of the some goods. Then medical radiological facilities. Of course, that many of them used short-lived radionuclides, but during the operation they are also contaminated, activated. So there is attention needs to those medical radiological facilities. Moreover, you might know that some of the very serious and critical radiological accidents happened because of abandoned medical radiological facilities, in hospitals also. So it is also very, very important. Then particle accelerators and other non-reactor research facilities, such as accelerator-driven facilities, they are not nuclear facilities per se by definition, but of course that during the operation of particle accelerators, they are contaminated and activated because of reaction of particle beams with materials, and they need also attention. Of course, size vary significantly. You can have relatively small linear particle accelerators, right, and like one room, and then you have this particle accelerator of international CERN institute that is actually huge, several kilometers. I do not recall what is the size, but it is such that it hits territory of Switzerland, Italy, and France. So it is really huge, many kilometers of the facilities and many facilities there. And they do have a really special team for radioactive waste management and decommissioning. Then we have to think also about the future facilities. I will speak about that in more details in another presentation, such as small modular reactors, maybe not yet about the decommissioning, but certainly about the design for decommissioning. Fusion facilities, the same design for decommissioning, though several research fusion machines were already also decommissioned. So there is first experience. Then we have to think also about the facilities used in defense industry, the variety of research facilities or training reactors, submarine reactors, they must be also decommissioned safely. And I noted here also special cases, such as nuclear facilities after an accident, that needs certainly a special approach and special considerations, let's say, even from the viewpoint of decommissioning strategies. Or maybe special cases can be also legacy reactors. Again, I will speak about it a little bit later on. That are we call it from the past activities. We do not have actually definition for legacy. I will show you one, but it is not official definition. So all of those facilities needs to be decommissioned. Okay, I believe that it concludes my presentation. If I may suggest, because I cannot hear you so well, I will send now by email to Anastasia the other two presentations, and as soon they will arrive, I can have a second presentation. After that, we will have a coffee break, and after that, I will have a last presentation. But bear with me, give me a minute to send email because it is on another screen.
Yeah, thank you for your presentation, and I guess we can answer some questions if there are questions.
Let's see, but you may You may bear with me because I can hear you so. So hopefully I will be able to understand. But let me first send the presentations. So there is presentation on there will be presentation on decommissioning updates and presentation on decommissioning of different nuclear facilities.
All right. So
Okay, they are coming. And if you will have some questions,
yeah.
please let me know. I will hear you very carefully.
Yeah. So thank you for this presentation. No questions?
This is fine. If there are no questions,
All right.
audio options, it's.
Okay.
I would like to improve my audio, but I somehow cannot. Test speaker and microphone. I don't know. Okay, at least I can hear you. Audio settings. Okay, I will leave it. I will better don't touch it. So Anastasia, email is coming, I guess, slowly.
Yeah, we got your presentations. Okay. So we will open it soon.
Oh, very good. Let's start with the decommissioning update.
Okay.
They may be still coming, but they will come.
The internet is a bit slow.
Yes.
Oh,
Yes.
yeah.
No worries
So
about it.
yeah, here it is.
Ah, very good. You have them. Start with the first one. First one. Yeah, this one. Very good. So can I start?
Yeah, you can start.
Thank you so much. So let me provide you with an update on decommissioning activities and projects. Of course, that I will focus more on activities of my department. I guess that Julia provided you with the update of nuclear safety department activities, but some of those activities are organized jointly, so I will tell you. Next slide, please. Here is a slide in general what we are doing to support member states. We are working on something what we call knowledge sharing and capacity building. Then we develop technical publications and safety guides, safety standards. We do have a variety of collaborative projects, workshops and technical meetings, conferences. There you can see billboard from the conference and some pictures from the meetings and site visit. We do have international decommissioning network established a long time ago. I will provide some information. We do have a technical cooperation projects. We also offer peer reviews on decommissioning. We do have a coordinated research projects, these collaborating centers, and we also cooperate a lot with other international organizations. Yeah, including OECD, NEA, WANO, EDA, what is European Demolition Association, interesting organization, etc., etc. Next slide, please. So I will start with the overview of e-tools or digital tools or electronic tools, whatever. How do you like it? There will be some more details later on, but in general, we do have networks under the platform Connect. Actually, those networks, one of the first was the International Decommissioning Network, but soon this idea of networks proved to be successful. And now we have many more networks in the field of remediation, red waste management, knowledge management, etc., etc. If you will visit the website platform Connect, you will see all of them. Then we do have developed a variety of e-learning modules, also on decommissioning, on radioactive waste management, remediation, disuse resources management. I will tell you a little bit more about those. We are still working on the concept of nuclear wiki, like to have technical articles and case studies in Wikipedia style. And we do have databases. I already introduced some of them in my previous presentation, but there are more databases that collect information about the radioactive waste management, spent fuel, and other important entities. Next slide, please. Yeah, we can come to the next slide. Yeah, here you can see. Yeah, there was animation. This big first proceedings from the conference should come like in the last, because it was published 1 month ago or something like this. But here you can see just examples. Yes, I will not speak about the details. You can see examples of nuclear energy series reports, of tech docs, of technical report series, example of proceedings, and very important examples of safety standards. The main is General Safety Requirements Part 6. But there are also specific safety guides on decommissioning, and even safety report series that provided some kind of relevant technical safety information. So just to let you know that we have a different series and different technical publications on different topics. Next slide, please. So I mentioned already International Decommissioning Network. It is one of the example of activity jointly managed by my department, by Nuclear Safety Department. And also we benefit from support by Technical Cooperation Department. And we have recently over 800 collective and individual participants. And as you can see, it was established in 2007, so really long time ago. There will be, by the way, biennial forum of the IDN from 8 to 12 December this year in Vienna International Center. So as is planned, we will have presentations of national and international experiences. Then topical sessions will be on application of circular economy principles in decommissioning, on decommissioning costing and funding, advanced dismantling techniques, decommissioning end states, characterization of facilities, and decommissioning by design. And we will have also panel discussion on sustainable approach to decommissioning and short 3 informative sessions, decommissioning and safeguards. I already told you about some considerations, outcomes from the IEA Artemis peer reviews, and interesting topic is also on artificial intelligence for decommissioning. Next slide, please. I already mentioned this global status project, so here are more details. Objective is to analyze the current global status and future trends around the world, by collecting, analyzing of data and considering them. And the second phase, we will have easy to answer questionnaires. We will do focused survey targets on some specific facilities. And we will also cover emerging topics such as funding, capacity building, sustainability, circular economy, etc. And key areas of focus are strategies and end state, main reasons for shutdown, decommissioning timelines and durations, costing and funding, human resources development, innovative technologies implementation, and sustainability and circular economy principles. And there is an overview of consultancy meetings and technical meetings held. So far we are fine. We completed the first round of the meetings, and we collected some data. And there will be, you can see timeline. There will be in March next year consultancy meeting to complete analysis of data and drafting the report. Later will be technical meeting, and later we will continue towards the report development. So this is information regarding this project. Next slide, please. Yeah, decommissioning costing. Nothing is more interested for the people in general, for the wide portfolio of the people, than decommissioning costing. It is a typical question after my presentation, and how much does it will cost? So we, as you can see on those pictures with the reports, there were developed a variety reports that cover legislative background for decommissioning costing, and also that provide some kind of methodology or even tools to provide to do decommissioning costing. You can see that there are a couple of reports by the IEA, but a couple more by OECD, NEA, but they were developed jointly with the IEA. They were only published in Paris, because it was easier. Probably the most important is international structure for decommissioning costing, ISDC, and based on this were developed many other reports and methodologies. And there was a long time ago certain gentleman agreement between the IEA and OECD NEA that they will focus more on decommissioning costing for power reactors, for nuclear power plants, and we will focus more on decommissioning costing for research reactors and other small nuclear facilities. And it is quite logic because practically all member states that do have power reactors, that there are members of OECD and EA. We have also them as a members, but we have much wider number of member states that do have research reactors, and they are not members of OECD and EA. So OECD cannot cover it. We can. So in safety standards, there are formulated obligations, for the operator to establish decommissioning costing scheme, decommissioning funding scheme for the future payment for decommissioning. One of the project that I would like to highlight is project called DACORD, Data Analysis and Collection for Costing of Research Reactor Decommissioning. We do have several publications on this, and it is not only like description how to do it. We also provided a calculation code in Microsoft Excel called CEREX that is quite advanced. And there are several manuals and examples how to do decommissioning costing for research reactor. Then there were developed reports jointly between two organizations on uncertainties. There was established expert group on costing for decommissioning of nuclear installations with development of additional handbook and application of the ISDC methodology to complex sites. We did have also several activities supported by Technical Cooperation Department. There was interest, for example, from Bangladesh, from South Africa on decommissioning costing and funding. Last year in December, there was a joint workshop on funding for the long-term nuclear liabilities. It was well attended. It was really very interesting. And now we have idea to support preliminary cost estimation for decommissioning of nuclear facilities with the development of a web-based software tool for decommissioning costing. So it is another piece of work to be done. Yeah, I will excuse you. Please excuse me for the minute. I need just to bring a little bit of water, but you can move to the next slide. I'm back. Thank you. The next slide is about the innovative technologies for advancing decommissioning. We have several projects in this area, so I will start with this one that is called New and Emerging Technologies to Advance Decommissioning, or in short, NET4D. And the project is kind of completed. My colleague in charge for it is working on the tech doc to summarize everything. It will be certainly interesting. And main objective of the project was to address emerging areas in application of innovative technologies in decommissioning. And growing demand of shutdown facilities is driving the need to explore applicability of innovative technologies that may bring an range of benefits in terms of efficiency, the minimization of radiation exposure of the workforce, facilitating the provision of information to regulatory authorities, and also facilitate the effective transfer of knowledge between workforces and between different generations of the nuclear engineers. Yeah, and in this project there were 3 working groups: one of management of large legacy data, second one on generation of 3D models from point cloud, and third one of digital model creation, selection and creation. And they do have such main conclusions. I will not read them. You will have it in my presentation. Please feel free to freely share it. Yeah, so as I said, I do expect that tech doc with the summary of the project will be available next year. Next slide, please. Based on demand from various member states, we started to work on concept of nuclear decommissioning management school. Okay, it is now provisional title that is used. In future, it can be nuclear decommissioning technologies school or something like this, depends on interest from member states. And idea is that, we will have a specific topics to be addressed and defined associated learning objectives. There will be strong link to e-learning materials. I will tell you a little bit more about that was developed, and our publications and also knowledge platforms. There will be to some extent standardized lecture materials, exercises, and technical visits. And overall, it should be well-structured, events for the future. And as I said, we may cover fundamentals of decommissioning, technologies, characterization, decontamination, dismantling, material waste management, and also decommissioning management, like soft topics, planning, costing, human resources, knowledge management, and again, material waste management, but more from the managerial topic. So for the time being, we have developed a curriculum for nuclear decommissioning school, and the pilot school will be hosted by Italian Sogin in Rome in October 2025. I would say, well, selection of participants is already closed. I would say that interest was 3 times higher that was possible to accommodate, because you have always some kind of limitations from the meeting room size and limitations for the site visits, so that's why it was limited. But we will continue certainly in the future. Next year is already planned, and we hope to have even longer than 1 week such a school. And I mentioned to you collaborating centers. So the Sogin, Italian Sogin, it is National Decommissioning and Radioactive Waste Management Organization, is one of the collaborating centers. So that's why we encourage them to host the meeting. Next slide, please. Knowledge management in nuclear decommissioning. I believe that this topic is very, very important. I saw it many times in my professional life that knowledge, records, drawings, whatever, was lost during the long-term operation and need to be reconstructed back or reverse engineering back, and it was really not so easy process. So that's why, in cooperation with the European Commission, we developed last year a taxonomy for the decommissioning of nuclear facilities. So to have a certain taxonomy ontology of the terms for them to support knowledge management. And objective of this initiative is to apply, develop taxonomy and ontology to nuclear decommissioning knowledge management systems through deployment a platform for data integration and to improve knowledge sharing between member states. Use data from various original sources, reconstructed data, and also used collaboration with other international organizations. So there are some key activities as defined. I am not exactly expert in this area, but I know those terms like semantic technologies or large language models or machine learning. and I can really imagine, based on my professional experience, that operation of nuclear facility is very long, and there can be situation where because of changes in the world, like in, let's say, former Czechoslovakia, or I saw it, I was last week on duty travel in China, and the premises of heavy water reactors, a heavy water reactor that is under the decommissioning, they do have a documentation in Russian language, original, because it was delivered by former Soviet Union in 1956. But of course, that nobody can read Russian language. So that's why, support of such knowledge management or machine learning or, artificial intelligence to support knowledge management is very important. There were again meetings organized. Actually, last technical meeting was last week when I was on duty travel in Beijing. So I cannot tell you more conclusions. I still need to speak with the scientific secretaries. But just to let you know that we are working in this area, and there are plans to continue and to have some more dedicated, not only report, but also platform that will support it in the future. Next slide, please. E-learning modules. I told you already that we have developed the original e-learning modules. I guess that in 2015-16, I was the main responsible person for it. So there are 8 e-learning modules in 2 areas. The first area is preparation for decommissioning. There are 4 lectures on strategy and planning, on inventory, physical and radiological inventory, on costing and funding, and on transition between operation to decommissioning. And the next module is on decommissioning implementation, again with the 4 lectures, project management, organizational and detailed planning, then technical aspects during implementation of decommissioning, redevelopment and reuse, and last lecture is with examples and practicalities. And even original modules were supported by Japanese Ministry of Energy. So we do have them in Japan and also in English and also in Japanese language. And they were widely used for Japanese universities, back to Japan for all of those years. And thanks to additional support from extra budget support from Japan, we developed updated versions of this e-learning. There are, from 2015, let's say 10 years ago, of course, that from that time you have more advanced visual opportunities, you have more projects to be referenced, you have more technical reports and safety reports to be updated. So really this e-learning enhanced. There are also new lectures. We did have consultancy meeting, international experts involved. Maybe next slide. And I am very pleased to announce that these new modules were released in June 2025. So if you will search in Google for the IEA e-learning on decommissioning, you will find it. I'm sure about it. And here is the list of improvements that were done. I will not read the details, but I can just say that everybody is very welcome to go through the modules. You will have some kind of certificate of completion, and we use them as a kind of mandatory exercise, mandatory preparation for participation in our events, such as the commissioning school. Next slide, please. Yeah, this topic on supply chain and innovative technologies, I would like to also only highlight that it was also covered. I organized a technical meeting or workshop on this with participation of member states, with international decommissioning program, with advanced program, and also with some limited decommissioning infrastructure. That week was also here a Nuclear Knowledge Management Conference, so we somehow joined them together, and we also covered interesting topic on artificial intelligence applications to support decommissioning supply chain, and we did have breakout group discussions around proposed questions. So there was also some kind of interactive discussions, and there was an artificial intelligence person at the end to do conclusions. It was fun. Next slide, please. This is another topic that I would like to highlight, site repurposing. This word is a little bit maybe difficult, uneasy. So simply means redevelopment and or reuse of the site for another purpose. And we took it in a relation with the stakeholder engagement, because it must be supported by the local communities and by the national communities. Otherwise, there may be not success. So here is just highlight that we did have, again, technical meeting last year with so many participants from so many countries with the various topics to be discussed. And it is important to highlight it because of, next slide, please. Because we decided to do a revision of a nuclear energy series report with the title An Overview of Stakeholder Involvement in Decommissioning, published 2009, so relatively long time ago. I believe that there is a plan to have it published into 2000, I don't know, 6, 7, let's see. So well over 15 years after the first report was published. And again, from that time, there are different developments in different areas. Because of accident happened, people and public, they are more sensitive about the, about the nuclear programs. But typically, when there is already at the site or locality, there is already nuclear program, somehow proof that is successful and it provides working opportunities and salaries and development of the local community. The public is usually more positive about the nuclear site repurposing, either for further nuclear use or maybe non-nuclear industrial use. We have to also consider that, those sites, nuclear sites, they are kind of high-quality sites. They do have access of roads, electricity, protection, water for cooling, local communities, that might support it. So repurposing is certainly a topic that needs our attention, and we are working on it. Next slide, please. I mentioned at the beginning coordinated research projects, or CRPs. So I am in charge for the one on decommissioning of legacy reactors. I will offer you definition of legacy reactors in my next presentation. The official title is Project on Research and Development to Advance Decommissioning of Legacy Reactors. There was a first kickoff meeting last year here in VIC, and second research coordination meeting in May 2025 in Beijing, hosted by China Institute of Atomic Energy. We do have participants recently from Egypt, China, Indonesia, Iran, Kazakhstan, Ukraine, USA, and Uzbekistan, and also observers from Bulgaria, France, Italy, Slovakia, actually another one from USA, maybe, for participants, it is a fixed deal. I cannot change it now at this stage, but for observers, it's still possible to add more. And project will continue for additional 2 years, and TechDoc will be the main outcome. Next slide, please. So another one, coordinated research project. with the full title, Deployment of Innovative Digital Technologies for Efficient Decommissioning of Nuclear Facilities, with acronym DEDICATE. Yes, you can find there, deployment, dedicate. You will find the letters there. So it is the new initiative, actually quite successful. There were received 15 plus proposals. I believe that now number is 16 or 17, but again, my colleague is out of the office. I was not able to check it. And the first research coordinated meeting will be in September this year, just after the general conference. And if you read the slide, you can see there wordings that is very advanced, like artificial intelligence applications or data management benchmarking, 3D modeling, digital twin, robotics, data management. So the project is actually about that, about the new, modern, innovative digital technologies that can be supported by artificial intelligence, machine learning, those kind of new intelligent tools that in my age I may not necessarily fully understand them, but I do understand that it is very important, and I certainly support my colleagues to work in this area. And I'm really open for any new learnings about it. So this project will be initiated this year. It will continue for additional 3 to 4 years. And yes, I hope that it will be very successful and very interesting. Next slide, please. Here is just a slide with just overview for your information of the other activities that we are going to have we are having. So later this year in November, end of November, last week of November, we will have a technical meeting on research and development to support the effective implementation of nuclear decommissioning projects. Then in mid of December, it is planned technical meeting on multi-criteria decision-making for the selection of decommissioning technologies. Or there is such a wording, performance indicator, so actually it is about it. That I mentioned already several times, collaborating centers. Collaborating centers is a standard IAEA mechanism to have agreement with a recognized institution, to collaborate in different areas. I do not know exact number of the collaborating centers. I should learn it, but maybe in agency we have now like 60 or 70 or 80, something like this, And we have recently established 6 agreements. We have Italian Sogin. I mentioned them already. We have a Slovakian Javis, what is also National Decommissioning Organization. We have a Norwegian Institute for Energy Technology, Korean KINGS, KEPCO International Nuclear Graduate School, Japanese JEA. It is 5. I forgot for one. The French EDF-DP2D, what is a center for graphite reactor demonstrator. We have recently approved agreement with China Institute for Energy, China Atomic Energy Institute. We hope to have a nice signing ceremony during the general conference. And we have expression of interest from another institute from the other country. So that's why 6 existing, 1 approved, and one with expression of interest. Then we also support technical cooperation projects on decommissioning. Just to explain we have in the IAEA Department of Technical Cooperation. But this department, it is more like administration of technical cooperation project, and they always invite technical officers from technical departments, safety, security, even energy, maybe even safeguards, and nuclear sciences and applications to support those projects, to provide technical content. So I am technical officer in charge for the decommissioning project in China of decommissioning of the heavy water research reactor. That is very interesting. Indonesia, they are not yet in the phase of decommissioning, but it may come in the future. They do have 3 research reactors, and I provided some expert missions. Iraq, it is certainly interesting because of nuclear facilities destroyed during the military conflict. Kazakhstan, we have already many interactions. It is on reactor BN350, and the real project will start next year. Slovakia, the first Czechoslovak A1 NPP that was shut down after an accident many years ago, and they do have very specific situation. Ukraine with Chernobyl NPP. Plus, we do have also, we might have also request from other countries that do not have TC project focused on decommissioning, but they request to provide them with some kind of expert mission or national meeting that will cover, for example, decommissioning coasting, or that will cover some management with some specific decommissioning waste. So recently I have such a request from Egypt and from Pakistan, but historically I was involved also in TC projects for Vietnam, Georgia, Thailand, even Hungary, many other countries. Yeah. And last point that is here is about application of circular economy principles to decommissioning projects. I have under the development first or 0 draft of the tech doc on this topic, and I will organize some events later this year and next year to advance this topic, to be highlighted in our publications. The next slide, please. I believe that it is the slide before the last, just to show you examples of external and internal cooperation of my department. So we cooperate a lot with Joint Research Center of European Commission, with World Association of Nuclear Operators. They do have interest in transition from operation to decommissioning. With European Demolition Association, with World Nuclear Association, etc. I mentioned already that with OECD NEA, there is an expert group on coasting for decommissioning. Within our department, we have cooperation with Waste Technology section, Research Reactor section, with the Nuclear Power Engineering division, with Nuclear Knowledge Management section, with Planning and Economic Study section. So various topics are covered by various entities. And certainly within the department, within the departments, within the IEA, we do have the most intensive cooperation with Department of Nuclear Safety and Security, Waste and Environmental Safety section. Here are examples of joint project on COMDEC, on completion of decommissioning, on MIRDEC, on small nuclear facilities and development of some reports or support of TC projects. There is also mutual support of events in VIC, which somebody organized, meeting. We are usually inviting, each other. We do have Artemis peer review missions, also organized jointly by 2 departments, or maybe some tailored peer review missions that we also organized jointly. And I believe that it concludes my presentation. I think that you mentioned that you would like to have coffee break at 10:30. No, in your case, 11:30. Right? So maybe we can have some 10 minutes for questions. After that, you may have your coffee break, and after that, I will provide the last presentation.
Yeah, that will be good. Are there any questions? Yeah.
Thank you for informative presentation. Please, could you please tell me about the technical cooperation in decommissioning with Egypt?
Yeah, I was in charge some years ago for technical cooperation project with research center in Shas in Egypt. It was focused on decontamination technologies, and part of the project was delivery of abrasive decontamination system. So it was a fully delivered and installed there. It is for decontamination of external and surfaces and internal surfaces of slightly decontaminated tubes. And recently, I received, the IA received a request to organize the national workshop on decommissioning, including decommissioning costing and funding for Egyptian authority in charge, that is in charge for construction of new nuclear power plant. So it is not the research center in Shas, but this your other authority. It will be certainly organized later this year. We are now discussing the possible date. Maybe it will be held later in November. So this is my personal cooperation with Egypt.
So I guess no more questions. Well, thank you for your presentation.
You are very welcome. So what is the timing now when I should be back for the last presentation?
The next presentation will be at 12.
12, what is my noon?
Yeah.
What is my 11? 11.
Yeah. So
Yes. As I wrote you, 11 is fine. I will provide this presentation, but 11:30 I will have other meetings. So I hope that we can finish by that time.
okay.
Yeah. Very good. So at 11 sharp, I will start with the last presentation.
Okay. Thank you.
Thank you so much. See you.
All right, so we're going to start.
Thank you. I understand that you have already afternoon, so good afternoon. In this presentation, I summarized some specificities and recent activities on decommissioning of different nuclear facilities. Actually, I focused more on recent activities. I had some more in the past, but it's probably not so, not needs to be highlighted now. So there will be information about the power and research reactors, about the fuel cycle facilities, fusion facilities, small modular reactors, and legacy reactors. So let's go through it. First of all, we do have a recent development on development of strategic roadmap for the commissioning of graphite reactors. You know, graphite reactors are located in different countries, in Western Europe, in Eastern Europe, also in Russian Federation. And the problem is with a large amount of irradiated graphite. I think that there are recently several 100,000 tons of irradiated graphite and what to deal with that. So for this was published last year the very good tech doc on managing irradiated graphite. It is the result of project GRAPPA, International Project on Irradiated Graphite Processing Approaches. And so this problematic is kind of covered by the IAEA publications. It includes characterization, retrieval, management, etc. of graphite. But after that, there is a question what to do with graphite reactor itself. So therefore, there was initiated project on development of this strategic roadmap. The report is now fully written and even approved by our internal committee for publishing, and it will go to publishing section soon for finalization. And this roadmap presents and describes the overarching aspects to be considered in defining graphite reactors decommissioning strategy, then the sequence of activities to be done as a major step to reach the decommissioning of graphite moderated reactor, and also identifies interlinkages, difficult word, between major tasks with the aim to focus on the target. So this is something what I can offer you on decommissioning of graphite reactors in terms of management of radiated graphite, report already published, and the strategic roadmap is to be published soon. Another more recent activity that we had at the end of last year was about heavy water reactors decommissioning. And it included both power reactors or CANDU reactors, but also research reactors. I think that in Russia there is one heavy water research reactor as well. But for this meeting in December in VIC, there was a technical meeting. There were Argentina, Canada, China, France, Japan, Korea, Norway, Pakistan, Romania, Sweden, and USA. So CANDU countries are there, plus a couple more that do have heavy water research reactor. Yeah, like Norway, for example, or Sweden. Then again, there were covered different topics about the decommissioning and radioactive waste management of heavy water reactors. They are certainly specific. They do have very specific design. I mean, power reactors with calandria, with horizontal tubes and continuous operation. But of course, that heavy water itself also caused issues because it produced a lot of tritium, and there may be even needed special detritiated plants plans to be in operation for the cleaning of the heavy water, to have heavy water pure, and also to avoid that so many tritium will be released to the environment. So all of this was discussed during the meeting. There will be some kind of small report around it. And I do have also interest from several countries with CANDU reactors and with heavy water reactors for the cooperation. So this is another one. Research reactors. I will summarize it quickly only on this side. You can see there a picture of technical report series on considerations on decommissioning in the design and operation of research reactors. It is a recent report. It was published either in November or December last year, so it is really, really recent. And actually on research reactors, I was involved, and also my predecessors were involved in many technical activities. So if you will in Google write IEA research reactor decommissioning, it will give you many previously published technical reports. So they are available and they are still valid. Plus, I forgot to tell you next slide. Now I can see it. So I'm sorry for it. I will come back to it. So it is about the graphite reactors, roadmap and management of graphite, irradiated graphite. And the next slide. We can go to the next slide. It is a summary of technical meeting of heavy water reactors decommissioning that was held in December 2024. And now we are really in the next slide. So you will see the picture. So just to repeat that this technical report series you can see was published at the end of last year. So it is really fresh and provides a lot of good considerations on decommissioning and the design and operation of research reactors. In addition to that, there are various other previously published reports. And in addition to that, we had also TC projects with China, previously with Egypt on this INCHAS research reactors. There are two. Georgia, Indonesia, I mentioned, Kazakhstan. In addition to BN 350, there are also activities on research reactors in Kazakhstan. Uzbekistan, we even supported the commissioning project of so-called Photon research reactor in Tashkent. But we have also many interactions with non-TC countries that do their decommissioning activities, and after they share lessons learned with us. So we did have them captured in technical reports, or we can have them discussed during the peer reviews also. So, for example, Austria, they have research reactor in the past. Australia, there were decommissioned Moata and Haifa reactor. Canada, they have multiple. Finnish reactor. In France, again, multiple research reactors operated by CEA. Germany as well. India, they captured lessons learned in this report. Japan, they do have multiple facilities operated by Japan Atomic Energy Agency. Norway, heavy water reactor. Republic of Korea, also reactors of the Kairi, etc., etc. Next slide, please. Then fuel cycle facilities. I showed you the statistics, but actually this topic of the commissioning of fuel cycle facilities was included in our program and budget cycle and resulted in the development of TechDoc. There was a great support and cooperation with Nuclear Safety Department. There were consultancy meeting and also technical meeting in Cherbourg in France, hosted by Erano with a visit of LAHAC. There were involved experts from Argentina, Brazil, Canada, China, France, Germany, Japan, Indonesia, Russian Federation, United Kingdom, USA, and also agency staff. Next slide, please. Because of my colleague that started with the report was retired from the agency, I after that took responsibility. So it includes a description of good practices, considerations, challenges, and also key aspects relevant to management of the resulting materials and waste, because they are certainly different than waste from the decommissioning of power or research reactors. Next slide, please. Here is the overview or content of the report. So it provides information about policy and regulatory framework, strategies and plans managing the transition, implementing of decommissioning, management of radioactive waste, and summary findings and conclusions. And there are also case studies by member states, 15 case studies by member states, so quite a few. Next slide, please. And report is fully, we can go to the next slide. Report is fully completed from my perspective. Yeah, good. From my perspective, actually, I already submitted final manuscript for our internal publication meeting. That will be actually next week. I will be on duty travel in Japan, but I will attend the meeting, from there, because of time difference, it's possible. So I hope that it will be approved, and it will be after that submitted to publishing committee. And again, it will after then do final layout and publishing. So maybe it will be published in the preprint repository by the end of this year, and as a hard copy report next year. So it's coming really very soon. Next slide, please. So fusion facilities. Next slide. We can go to next slide. Fusion facilities. I have a working tech doc with working title under the development, decommissioning and waste management considerations for DT magnetic confinement fusion facilities. So it covers really recent experience with decommissioning and red waste management, and also design for decommissioning of the future fusion facilities. Experts were involved from China, France, Italy, Japan, Russian Federation, UK, USA, plus also ITER and Organization Fusion for Energy. We did have a consultancy meeting and also technical meetings in February 2023 in Cadarache with visit of ITER. And again, the same situation, the colleague that was in charge for it was retired from the agency, so I accepted the responsibility. Next slide, please. So the report was developed very well in cooperation with Safety Department. And here you can see also mentioned is nuclear science and applications physics section. So actually 3 departments were involved in this. From my perspective, it's fully developed, and it is like 300 pages. It is really not trivial report full of scientific considerations. It's really very substantial, very fundamental. And it is now under the internal approval process. So after comments will be raised, I will work on the comments, and I hope that it will be approved by our internal publication committee by the end of this year. So quite advanced stage of development. We can go to the next slide. Small modular reactors. So it is about the design for decommissioning. Official title is now Considerations on Decommissioning and the Design of Small Modular Reactors. It will be technical report series. There were consultancy meetings and also technical meeting. We developed a survey on SMR design for decommissioning. And it was well coordinated with our internal entities, that are somehow deal with small modular reactors. Moscow State University, your department was also involved. It is there stated between the contributors. And report was approved by our internal committee, and it is now with publishing section. It will be fully edited, so it will take some time to have it completed, but I expect that it will be published maybe later this year, maybe at least as the preprint repository, or early 2026. So this is also quite advanced report to be available soon. Next slide, please. Yes, and in the report there is a discussion on experiences, best practices, and lessons learned from the commissioning of other nuclear facilities that may be relevant to SMR design for the commissioning. Thoughts regarding planning, costing, and implementation of the commissioning strategies. And the SMR, again, they will be different, kind of different from recent facilities. So there are important aspects such as modularization, selection of materials, contamination control and characterization, measures to support dismantling operations in advance, keeping of operational knowledge and history, lessons learned from the commissioning of large research reactors, and maybe also some specific decommissioning approaches. For example, return of primary module back to the country of origin, like we can see for disused sources. There are also wider considerations on circular economy and safety and sustainability, and there are some examples or case studies from France, Japan, and Slovakia. Next slide, please. Legacy reactors. I mentioned it already several times, and though we do not have official definition in our safety and security glossary, I can offer one that is kind of written already in one of my previous reports, and maybe definition would be good like this: that legacy reactors are those lasting from early development of a country's nuclear activities. Their activities can be scientific, defense, or power-related, and have not yet undergone extensive decommissioning to terminate the license. Examples might include early prototype of first fleet of research or power reactors. These reactors typically feature varying states of disrepair due to a lack of consistent maintenance, a lack of proper inventory recording, and a lack of proper regulatory framework, or at least such framework that is not up to the modern safety standards. And these reactors are often characterized by varying degrees of radionuclide contamination, the presence of disused buildings and infrastructure awaiting decommissioning, and surrounding land that has been affected by the past operation. We can go to the next slide. And actually, on the next slide, you can see just repetition from my CRP on research and development to advance the commissioning of legacy reactors. What is here extra, I included here certain matrix that we updated during the last meeting in Beijing. You can see participating countries and topics. I know that this is smaller, but you will have the presentation later on available. And the topics that are in columns cover logical steps in decommissioning, from the beginning to the end. And we simply want to be sure that these proposals within the CRP will cover all topics. So this matrix proves that it covers all topics. Okay, and I believe that it is my last slide. So it concludes my presentation. I maybe delivered it a little bit quickly because I will have soon another meeting. My apology for that. But feel free, Anastasia and Andrei, feel free to share my presentation with participants. I have absolutely no problem with that. And if there will be, interest in some follow-up cooperation, you can also contact me. Again, I should place elsewhere my email address, but I think that it's quite easy. From my name, v.michal@ia.org, I have absolutely standard email address. So Anastasia, Andrei, over to you.
So thank you for your presentation. Are there any questions? No? All right, thank you.
I would like to thank you once again for your attention. I wish you a very successful completion and closing of the training course. I need to leave now because of another event, but it was my pleasure to provide presentation. And Anastasia, Andrei, you can rely on me for some future activities.
Right. Thank you again.
Thank you. Goodbye.
Goodbye. Так, вы нас слышите?
Да, меня слышно? Добрый
Да,
день.
вас тоже слышно. Хорошо.
Отлично.
Так, а презентацию вы показываете?
Да, сейчас давайте я
Ага.
попробую поделать. Я просто через браузер захожу, потому что у нас тут не скачивается. Мгм. Мне просто интересно, как мне надо, в каком формате поделиться, чтобы было в режиме презентации видно в Zoom, да, а у меня были мои notes, вот эти, которые внизу. Так. А у меня сейчас пишет, что недоступна функция поделиться экраном.
Ну, тогда можете прислать презентацию, мы ее откроем.
Так, сейчас попробую. Да, сейчас я тогда сохраню в PDF, чтобы оно полегче было.
Мгм.
Ну и тогда я просто буду просить переключить слайд.
Да, да,
Ага, ну все, в остальном все работает, вроде все нормально.
все отлично.
Мне остаться тогда сейчас уже на эти 10 минут или как, или переключиться?
Да, оставайтесь уже.
Хорошо. Все, тогда просто экран пока погашусь. Только скажите, на какой email прислать. Сейчас давайте я в чат отправлю свой email рабочий. Вы мне можете какой-то просто тестовый? Так, я вот отправила свой email.
Юля, привет. Сейчас попробуем. тебя микрофон выключен пока.
Ага. Да, отправлю тебе на Gmail, у меня есть почта твоя. Или куда лучше отправить?
Сейчас мы в безопасности. Так, попробуй сейчас.
На почту.
Нет, демонстрацию сделать попробуй.
Сейчас. Так,
Юля, привет.
привет.
Все видно.
Так, а если я его включу сейчас вот так?
Да, мы все видим. В нормальном
Прекрасно.
режиме. Ну,
Ага, все хорошо.
Ладно.
У меня все правильно открывается. Все, тогда ждем без 15, да? Через 5 минут начинаем.
да, можно начинать, все здесь, поэтому...
Ну все, хорошо, тогда можем
Мгм.
сразу. На английском, да, мы читаем?
So, dear colleagues, we continue with the next lecture given by Yulia Gorlova. So, Yulia, please.
Thank you very much, dear colleagues. I know there are some people I know well in the audience, but my welcome to all of you. I represent IAEA, Decommissioning Safety Unit, and before that I used to work a long time for SATAM for 12, so in decommissioning remediation integrator. And today I would give you a lecture on kind of information about IAEA requirements and guidance for decommissioning. This topic, I think, quite basic, but good to refresh, even if you're acquainted with that, because just based on the interaction with member states and from my personal experience, I know that some things sometimes we don't know that they already exist and are well covered and proposed as the support to member states in questions and in topic related to decommissioning. So first of all, about IAEA safety standards, they consist of 3 sets of publications. You see here in this left side kind of a wheel where the central document is SF1 that establishes fundamental safety objective and 10 safety principles. These principles provide basis for requirements and measures to protect people and the environment from harmful effects of ionizing radiation, and for safety of facilities and activities that give rise to radiation risks. Basically, safety means, as I put here on the screen, it means protection of people in our context, protection of people and environment against radiation risks, and safety of facilities and activities giving rise to radiation risks. So here we talk about that's kind of it's put in the safety and security glossary, and includes activities related to all authorized facilities dealing with radiation. All of these documents, all of 3 levels of the documents, the major ones, they are based on international consensus on what constitutes a high level of nuclear safety, and they represent a global reference for protecting people and environments. So, as I said, Safety Fundamentals is the central cornerstone document. It provides fundamental objective for safety and principles. I will also briefly cover it a little later. And there are levels, other levels of IAEA safety documents. You see this red or like kind of ruby series. This is safety requirements. These are requirements that must be met to ensure protection of people and environment. now and in the future. And in case they are not met, in this case, measures might be taken to reach or restore the required level of safety. And this green series, green level of documents, here is here is this branch devoted to topic of decommissioning and waste management. So safety guides, this level of documents, they describe in more detail how these safety requirements can be met and how to comply with safety requirements. Just a moment, I try to switch, but it doesn't switch. No. Okay, now it works. So here in the slides you can see the documents, just bunch of documents that relate to decommissioning activities. The level of safety requirements is the GSR Part 6. This is General Safety Requirements Part 6. That covers the more like obligatory requirements to perform decommissioning safely in all stages. I will also cover it in brief, and there are two more documents that contain basic information on how to comply with these requirements. These are decommissioning of nuclear power plants, research reactors, and other nuclear fuel cycle facilities. SSG-47 and SSG-49 for kind of very similar and related document, but it is for decommissioning of small facilities, medical, industrial, and research facilities. Other documents that belong to this group and also support decommissioning activities are the General Safety Guides GSG-18 on the application of concept of clearance. It was published in 2023, so it's a fresh one. And two documents that are currently under revision. These are WSG-51, Safety Guide on Release of Sites from Regulatory Control on Termination Practices. And another one is WSG-52, Safety Assessment for Decommissioning of Facilities. These two documents are currently under revision, so this one on release of sites, it's already in very advanced phase, already now being commented by member states, and their comments are being responded. And safety assessment, it's a little bit in more less mature phase of revision. So also our team now works on these documents, and it should be available, I think, in some time frame of maybe two years. Also, this decommissioning of facilities, GSR Part 6, it was dated 2014, so the review cycle is around 10 years normally, so now it's being in call for revision, and now we internally analyze and try to see what gaps it might have. So we have in our plan to revise these high-level documents as well. And here I tried to put in one slide more or less all of these related documents, and to show their scope and what they cover. So this SF1 fundamental safety principles, as I mentioned here. So there are 10 principles. I can just quickly go through that, because then it unfolds in the lower level documents into some requirements and exact guidance on how to fulfill them. So these 10 principles in SF1 are responsibility for safety. That states for that primary responsibility for safety resides with the organization responsible for facility. Then role of governments, it states the efficient legal and governmental framework needed for safety, including regulatory body. Principle number 3, leadership and management for safety, states for effective leadership and management to be established and sustained for organizations that are concerned or facilities and activities that give rise to radiation risks. Principle number 4, justification of facilities and activities. Also, it states that the benefits should be more than the radiation risks, so there should be this kind of leverage. Principle number 5, optimization of protection, states that protection should be optimized to provide highest but rational level of safety, reasonably achieved. Number 6, limitation of risks for individuals. This includes explanation that measures for controlling radiation risks must ensure that no individual bears unacceptable risks. And here we talk about some kind of working in couple, limiting of doses and risks along with the optimization of protection. Principle number 7, protection of present and future generations. Here we talk about people and the environment should be protected, must be protected against radiation risks. And the last one is prevention of accidents, emergency preparedness. So these explain necessity to provide this framework and protective actions to reduce existing or unregulated radiation risks. Here, this article talks about natural origin radiation risks such as radon exposure or former activities that were not in previous times in kind of 50 years ago, 40 years ago, were not well regulated, so they are kind of legacy that are to be dealt with, and remediation situations also from some past activities, for example. This is concerning this big high-level fundamental safety principles. Then, as I mentioned, there is this general safety requirements part 6 for decommissioning facilities. I will give a brief explanation of it in the next slide. And then next level documents, ISSG-47 for larger facilities, for major all types of facilities, and for those smaller facilities, ISSG-49. Here you can see, I hope you can see well also, their contents. So basically the table of contents is the same, and it's only some features that relate to differences in these types of facilities and nature of their activity, also magnitude of related hazards, etc., etc. So that explains in more details situations for these types of facilities. So GSR Part 6, here just I will mention a little bit that this document was decommissioning of facilities. It's like obligatory document for following. It was issued in 2014. As I said, we plan to revise it soon in the coming years. And this document establishes internationally agreed requirements for decommissioning of facilities based on this high-level documents, fundamental safety objective and safety principles. And this document presents safety. It's established for all aspects of decommissioning, so it covers the stages from siting and design of facility, everything like construction, commissioning, operation phase, and also decommission. So this we mean here that although decommissioning is the last stage of the facility life cycle, we start to think of that and to first mention it and reflect it in related documents already from the early phases, early stages of facility lifetime. So by that we mentioned that already in this early stages, documents for design, documents for construction, it should already include some statements, some very brief preliminary description of how do we plan to decommission this facility in the end of after the end of its operation. So this is kind of current suggested and recommended approach, so that it wouldn't be only happening like before, immediately before decommissioning. Yes, because you need to make sure that you have available funds for that. You need to make sure that by the time actually we reach to the stage of decommissioning, we have thought of all necessary steps. We were keeping necessary records, etc., etc., and we can prepare in an efficient manner for this decommissioning project. Here you can see the contents of this GSR Part 6 decommissioning facility. So it contains, as you can see in this blue, in the left part, contents of the documents. So it features some basic wordings, statements on protection of people and environments that transcribe into 3 requirements of GSR Part 6. And then if you go later into this more detailed documents of this green level of documents 47 and 49, this is specific safety guides, they explain, based on all of these requirements, how they can be implemented by the utilities, by facilities, and how can they be regarded by regulators and other interested parties. So you can see the requirements of GSR Part 6. I don't know, I can just mention some important things here without, it's very basic, so I think quite familiar to all of you. So just to mention that here in decommissioning facilities, we are talking about, in this document, about planned exposure situations, how it's regarded by basic safety standards. This means that this is about activities, facilities and activities whose activities were planned. So it's not that something happens all of a sudden, like some accident situation. So we are not talking here about some legacy facilities that were absolutely like surviving some certain unclear situations in the past, a long time ago. But this is about planned exposure situations when we were planning to use this source of radiation or this nuclear materials, and we responsibly deal with that also in the phase of decommissioning. Also important to mention that we use a principle of graded approach in these documents. So this means that the level of scrutiny with all the documents, with all the actions, both on side of utility or licensee and on side of regulator, it commensurates with the degree of hazards, potential hazards, and complexity of the facility. So, for example, the smaller facility, the less scrutiny you would have in this case, and the more complicated is a facility, complex facility, the more detailed should be all related documentation, all works involved, etc., etc. So this is done to optimize the efforts, but in the same time to optimize and to provide the necessary level of safety for all the processes involved. Also, what to mention? Major principle, one of the major principles that the responsibility stays with the licensee primarily. Yes, and that includes selection of decommissioning strategy, includes preparation and submission of initial decommissioning plan and its updated versions. Also importance of implementation of integrated management system, also for decommissioning activities, and importance of having in mind necessary financing for decommissioning. So financial provisions should be organized and set by national legislations. And like, for example, number 12, conduct of decommissioning actions, licensee shall implement decommissioning plan. That includes also activities related to derived waste management in compliance with national regulations, and there are some special provisions in case deferred strategy for dismantling is for decommissioning is in place, and other things. So this is a kind of basic document covering the major requirements for decommissioning. And now we will get to the point of SSG 47 and 49. So these are the documents that explain how these requirements that I just showed in GSR Part 6, how they can be met. So specific safety guide 47. This is the document called Decommission of Nuclear Power Plants, Research Reactors and Other Nuclear Fuel Cycle Facilities. It was issued in 2018. This document supersedes the earlier one that was issued in 1994. Relevant document, and also the one on decommissioning fuel cycle facilities of earlier time. So this document currently is in revision that is in use. Its objective is to provide guidance on, for all interested parties for planning, conduct, and completion of decommissioning, including termination of authorization for decommissioning. And as I mentioned, this document also applies to planned and authorized activities, planned exposure situations and authorized activities. Here you can see the, in the left hand side part, you can see the contents. So major aspects covered here. So it includes some introductory chapter, and general provisions like protection of people, environments, and responsibilities of the parties associated with decommissioning. So here I mentioned what larger level documents. They also refer to SF1 and GSR Part 1. And this block, I also grouped them just kind of by their sense and content. This block, sections 4 to 7, they contain information on safety, planning, and managing of decommissioning projects. It includes also the chapter on decommissioning strategy, financial aspects, planning, etc., etc. And these sections 8 and 9, they are about decommissioning conduct and completion of decommissioning. So the actual stages when you perform the decommissioning actions and reaching the phase of end state and release of sites, hopefully, from regulatory control. Also, the document contains a number of appendices and annexes. I will now talk a little bit in more detail about each of the sections of this document. So, as I said, this first block of 3 sections, they include general provisions. Here I provided some statements that are, let's say, important to highlight. So here we talk about administrative, and that's actually the definition of what decommissioning is. It is administrative and technical actions taken to allow removal some or all of regulatory controls from unauthorized facilities. And the aspects of decommissioning covered here also includes some features such as minimization of radioactive waste that is generated during the decommissioning project, and also such aspects as planning of decommissioning, records keeping, and all related topics of this general application, let's say, that are to be considered throughout the whole lifetime of the facility. And what else to mention? That also we mention here that decommissioning actions, all of the decommissioning actions, are carried out to achieve progressive and systematic reduction of radiological hazards during the decommissioning. And here it's important to mention, it's also mentioned in the documents, that along the process of decommissioning, there is such feature that radiological hazards gradually reduced, but we need to bear in mind that industrial hazards, so non-radiological hazards of different kind, can be happening at different stages of decommissioning work, and that also requires certain planning, management, and provision of necessary support to staff, training them, and so that it could also be considered, because these risks, such as, I don't know, falling from height or some thermic burning or whatever, so dispersion of some hazardous materials like asbestos, etc. So this should also be taken into consideration in the relevant planning before the decommissioning, and followed and monitored during the decommissioning implementation. And also to mention that important aspect here, that decommissioning actions are done on the basis of planning. So we prepare initial decommissioning plan and then gradually upgrade that in the flow of operational phase. Because, for example, we get some information from operation on modifications of the facility if they take place, or just in case, hopefully not something happens, some small incidents or something, it should all be also included in case it changes somehow or influences somehow future decommissioning by imposing additional contamination, or there are some spillages that were happening during operation time, or whatever else. It should also be included in this update plans. And somewhere in before decommissioning begins, in some transition phase, which is still under operational license, normally the final decommissioning plan is prepared with consideration of all this operation history, and with consideration of characterization works done, to provide description of the facility and actions needed to decommission it. And this also includes, this planning also includes some additional documents that can be a separate document, or they can be incorporated in a decommissioning plan, such as safety assessments, environmental impact assessments, and other documents that can be part of a set for convincing the regulator that you have everything in place, planned to provide the decommissioning project in a safe and efficient manner, and to reach the planned end state. Elizabeth, I will be talking about that tomorrow in the presentation on decommissioning plan. So next bunch of chapters in the document are about strategy, planning, and project management. Here just I reference some important aspects, such as that decommissioning is also a licensed activity. So as all the other important activities or stages of lifetime of facility, it should receive the license for decommission or authorization for decommission. And also important to notice that decommissioning is conducted as a project. So it's a kind of project with all normal features of a project, but here we add to some basic set of constraints, which is time, budget, and scope. We also add this important factor of this safety being the cornerstone. So it's not really always possible to play with these parameters, and and in any case you cannot reduce or neglect the safety aspects when you talk about decommissioning project. So and adequate planning. Yes, once again, just to mention that these are supportive activities that are absolutely crucial. So planning is happening in starting from early phases of facility, nuclear facility or radiation facility, starting from siting or design phase. Yeah, of course, we understand that there are these older facilities that when they were established, created back then, there were no such strict rules, strict regulation with regard to decommissioning. So they were not plans conceived with decommissioning taken borne in mind. Yeah, so it's a little bit more complicated about that, but nowadays it's absolutely crucial and inevitable that we start planning decommissioning well in advance. So basically that helps also to keep the financial part more sound. So because you go through all this details on, for example, bearing decommissioning in mind, so it's like decommissioning by design, what we call. So from the these early stages when you conceive a facility or when it's designed, even such things as materials, their potential for contamination, for activation, this is all considered when choosing materials, so that it would be there would be less waste, less contaminated contamination and activation during the decommissioning phase. And some, of course, that relates to all phases. So in all phases, this should be borne in mind, and it's the best. It's really desirable that these aspects are considered in all phases. Number 8 and 9, these sections on conduct of decommissioning and completion of decommissioning. I'm not talking here in detail about all this, let's say, technology aspects of decommissioning. I think maybe, I think that yes, it was covered by my colleague Vladimir Michal from section of nuclear Department of Nuclear Energy, because both of our departments, they deal with aspects of decommissioning, but they are concentrated on technology. We are concentrated on safety, but of course it's all interconnected, yeah, and you cannot separate so much one from another. But here, just to mention this major aspects that are highlighted in ISSG-47 for conduct of decommissioning phase. Here I would mention that important to state that it goes in line with national regulations. When we implement the conduct decommissioning, it is based on implementing of decommissioning strategy chosen for the project for this exact facility, as it is described in final decommissioning plan. Also, hazards, as I said, they will be reducing, but we need also to think about non-radiological hazards that might be arising. And by the way, sometimes it happens often it happens not in some linear kind of approach, but or linear type. But when you gradually remove some engineering barriers, it can have some kind of peaks for hazards when staff works with dismantling, decontamination, but mostly with dismantling, and this should also be borne in mind that there are some peaking times in the decommissioning project when hazards, and including radiological hazards, can also be increasing and then of course decreasing. So decontamination of activities, they can be happening before, during, or after dismantling, so it's applicable for all phases of decommissioning. When we talk about techniques and methods and technologies, ISSG-47 suggests that preference should be given to proven techniques, and demolition phase, it may be needed or may be not needed, considering the chosen end states. Records are to be kept, regulatory oversight is vital, emergency arrangements should be also present, and we remember about waste management, because there will be waste that is also derived from the decommissioning activities, from decontamination, from dismantling, demolition perhaps, so during that process. And completion of decommissioning, when we reach the end state, we also proceed with a cleanup of the site if it's necessary, and then licensee when it demonstrates that end state criteria can be reached based on final radiological survey, then the facility can be considered no longer existing, for example, and the site can be released. if we are not talking about multi-facility sites. And here you can see the appendix and annexes that are provided for this SSG-47. These are considerations for safety assessments, suggested structure and content of some of the major documents, such as final decommissioning plan, final decommissioning report, structure and content of final radiological survey reports, and some example of decommissioning related documents. SSG-49. So this document is for, it's very similar, so I will just stop here on some items that are different from SSG-47. So basically it has the same structure of the document, but it relates to decommissioning of smaller facilities, mostly about medical, industrial, and research facilities. Here we also cover research reactors, but you remember it's also in the scope of SSG-47, the big research reactors. Here kind of consensus was reached that we talk about facilities that are kind of 1 megawatt of power and below, so the really small ones. The document was issued in 2019, and it was superseding the document's older one of 1999. Really old one. The objective is to provide guidance to all interested parties on meeting requirements for planning, conducting completion and of decommissioning and termination of authorization for decommissioning, more or less same as for larger facilities. And it's also related to activities planning decommissioning for in all phases, starting from siting and design of facility and until the last phases, including termination of authorization. Again, as with the SSG-47, this document, SSG-49, applies for planned exposure situations and for authorized activities. Here you can see similar approach to SSG-47. So also we have the contents including some general provisions, strategy, planning and project management, decommissioning, conduct and completion, and a number of appendices and annexes. Here they give some examples of related safety documents for small facilities, including contents or considerations for safety assessment for decommissioning of small facilities, factors influencing selection of decommissioning strategy for small facilities, and some guidance of applicability and supporting documents for decommissioning of small facilities. So more or less it's same approach, as I said, as with SSG-49. I think it's no use to read everything again, but here just to mention that how does it differ from SSG-47. Here, it is especially important to talk about graded approach, because of course, as far as we are talking about really small facilities, such as, for example, facilities with sealed sources, unsealed sources, waste management facilities, accelerators, or the small research facilities. We talk about facilities with whose construction has more or less complicated design. And of course, it also refers, in most of cases, less complicated and less scrutinized planning for decommissioning, although of course it has all the features of same decommissioning project, just with less details, less factors, some aspects to be covered in scenarios for decommissioning, in safety assessment, etc., etc. But more or less it's the same approach, but just taking into account this graded approach. Again, decommissioning actions are to achieve progressive and systematic reduction of radiological hazards. Take all the sections taken on the basis of planning and assessment. And it is recommended, if we talk about decommissioning strategies, recommended to apply immediate decommissioning, immediate dismantling option. But also there are cases when deferred dismantling option can be preferable. For example, to allow decay of radionuclides that are present, to reduce contamination, and to subsequently reduce the dose to the personnel during decommissioning. Again, as I mentioned, that's an authorized activity, so license or authorization can be required for performing these activities. And on completion of the decommissioning project and reaching the planned end state, authorization for decommissioning can be terminated, and site can be possibly and hopefully reused for other purposes. Site can be released for unrestricted or restricted reuse, depending on whether the what release levels were reached and what reuse option was indicated or planned and mentioned in final decommissioning plan. This block about management and financing, planning of decommissioning, again, it's more or less same approach as with larger facilities. Here we also a little bit more complicated sometimes. The fact that if you compare small facilities to big power plants, for example, it's not always the case that necessary decommissioning funding is in place. So, especially if we talk about some research facilities, it might be the case that governments or some governmental organizations might need to step in to ensure that decommissioning is supported financially. Sometimes, but of course, if the facility was producing, for example, radioisotopes or medical applications or something else, then of course they should be also dealing with this aspect and putting into plan necessary financial funds for future decommissioning. And same as for the bigger facilities, planning of decommissioning includes initial decommissioning plan, updated plans, final decommissioning plan, based on which authorization for decommissioning is issued by a regulator. And such aspects as public involvement should be considered. And these are some exact cases for situations that can be. For example, sometimes a facility might not reach its full operational phase timeline, but due to different reasons, sometimes facilities close earlier than it was expected due to technical, political, even social, or some other factors, financial factors. So this should also be kind of considered for planning in decommissioning planning. Conduct and completion, more or less, also same approach as for larger facilities. Here we talk about implementation of decommissioning strategy, and all the actions they are done based on the final decommissioning plan, on the actions listed there, with a due consideration of safety aspects and also with consideration of environmental protection plan. And here there might be different decisions to be taken, whether you need to remove the sources, that's one case, or do you need to decontaminate, do you need to dismantle the facility, or maybe it's just, I don't know, replacements of some big medical equipment. And for example, you keep the bunker for that for future use. Do you need to demolish or not? And some other things here. Yes, and in case of small facilities, also as I mentioned here, this is also in the project activity that's considered to be a project, a decommissioning project, and it involves a lot of additional works to be done and some supportive activities such as analysis, studies, etc., etc. And team should be prepared to work on such projects. And for personnel, it's especially important to note that these are activities in which most probably people from the facility did not work before. Yes, so they were working on operation facility, so they need to be trained, to be well equipped and well prepared to perform the activities on decommissioning. Or there might be a decision taken to invite some contractors to perform these works, because yeah, that's also a matter, especially in small facilities are concerned. Maybe it doesn't make sense to, or maybe it's not even possible to get the right staff internally, and facility would have to invite somebody who has relevant experience. Again, just to mention that here decommissioning scope is based on the graded approach. And a couple of words, I didn't have it covered in ISSG-47, but just a couple of minutes on that. When we talk about completion of decommissioning projects, here I presented kind of a sequence that when decommissioning actions are completed, we perform the final radiological survey. It's then presented in form of final radiological survey report to regulator in order to demonstrate that objectives of decommissioning that were described in the final decommissioning plan are reached and fulfilled. And based on that, if all is fine, then the final decommissioning report that summarizes all the activities taken leads is submitted to regulator, and application for release of site is also submitted to regulator to terminate the license. Of course, in case we have not reached decommissioning end state, there can be some cyclic processes here to return to previous phases. For example, if a final survey showed that we didn't clean the site to necessary extent, to necessary those constraints and those release levels, then we need to decide whether we want to clean more or we need to change the end state. So there are different options for that. Yes, and in the end, the site should meet the end state criteria. And if they are met, then the site is released from regulatory controlled. If not, then reassessment should be done, whether we can reach it, whether additional actions are needed, or a new end state can be defined. So based on that, again, as I mentioned, there are options for unrestricted release. So it's like what we call greenfield, but normally we don't refer to that in IAEA, or restricted release, when you stipulate exact restrictions that are set, for example, for use of the site, for time of using, duration of using the site, or for whatever can be different types of, like no fishing here, no agriculture, or can be used for some parking space or for roads or for some certain types of facilities. So that is all done based on the optimization of protection principle. And I just have a couple of minutes left before your lunch. Here are appendices and annexes that are included in ISSG-49. Here you can get acquainted. It's all available online, of course, and so you can download these documents and see some suggested considerations for safety assessment for small facilities, factors influencing selection of decommissioning strategies, and some annexes giving some useful information for small facilities when you plan some supportive documentation. Also, just to mention that to get more familiar with practical side of decommissioning of small facilities, there was a project implemented by IAEA. It's called MERDEC, decommissioning of medical, industrial, and research facilities. We have finalized this project last year, and now we prepare the publication. It will be a tech doc on decommissioning of small facilities, and it will include some overarching aspects that are common for different types of small facilities, and there will be a big section containing case studies. So it should also provide some practical use to see how the projects on decommissioning of small facilities were implemented in different countries, and with consideration of different types of small facilities. So this should be published next year. So we will be sharing information about that. So practically on time. If you have any questions, sorry, perhaps we really have small time for questions, but you're welcome.
Yeah. Thank you, Yulia.
So I stop sharing.
Any questions?
Hello. Hi, Yulia. Thank you for the great presentation.
Hi, Gem. I don't see you, but I hear your voice.
Oh, you hear me? Okay, nice.
Yeah. Hi.
Regarding your presentation about GSR Part 6, it's been already 11 years from the last edition of that series. So do you see any improvement needs on GSR Part 6 requirement topics? There are many requirements you list that's listed. For example, like in requirement 14 in the radioactive waste management needs for decommissioning or something like that. I wonder if you could inform me.
Well, it's now we are in the phase of kind of internal analysis of that, and we were discussing with colleagues. We plan a broader discussion during meeting of International Decommissioning Network that will be held in Vienna in December. So I asked to include this topic into the agenda so that we could gather some inputs from the member states, from people who work for the industry in different member states, and to analyze what gaps exist, what might be needs. Right now we see that, yes, indeed, there are certain needs. Like, for example, now we talk a lot about future decommissioning of small modular reactors. And we understand that some types of facilities, like SMRs, like maybe fusion facilities, they are currently not well covered. So we feel that there will be really need for some introduction of some new requirements or update of requirements in this regard. Also, of course, it will also might cover relevant aspects of waste derived from decommissioning, but mostly it will concentrate on the decommissioning itself. But as far as, of course, yes, it's more than 10 years, and we understand that now it's coming really to the point that we need to revise it. So we will be looking more broad on what can be potential gaps for that. But this novel types of facility definitely one of the aspects that might need to be somehow considered.
Thank you. Vladimir also mentioned before you on his presentation that it will be discussed on the December technical meeting on this aspect.
Yeah, so by the way, just to give you this information, if you are interested, it's possible to apply to become a member of International Decommissioning Network, and it's not organization, it's each individual. So if you represent your nuclear industry, like your member states, you work for some organization, I don't know, whatever, regulator or licensee or TSO or whatever, you can, so you're a professional in this area, you can apply through IEA site. First you need to register in Nucleus, and then you can apply to become a member, and then you can apply to actually also attend this meeting. It will be I think in both in person and also in virtual format, so that more people could attend.
Well, that's great. Thank you.
Thank you for the question.
Okay, if there are no any other questions, then let's thank the speaker again.
Thank you very much.
So thank you, Yulia. We'll see you tomorrow. Yeah, as well.
Yeah, see you tomorrow. So my pleasure as always.
Okay.
Bye-bye.
Thank you. Thank you.